everyone, welcome to the lecture series of operating systems. So as we have completed our first unit, now we'll be starting our second unit. So coming to the syllabus of second unit, in this unit you will be learning about the process management and the scheduling algorithms. The unit objectives of this second unit is, in order to introduce the notation of process. It also describes, you will be able to describe the various features of process, including scheduling, creation and termination of process. And then you will be able to explore the inter-process communication, as well as you will also be able to describe the communication between the client-server systems. Coming to the table of contents, that is what we are going to learn today is the process concept, what actually the process is, the process state diagram and the process control block. So what actually is a process? A process is thought of an program in execution. So in the sense, right from the starting of this lecture series, we have been discussing that in order to execute each and every program, in order to execute an application or whatever the things you see on your screen should be brought into main memory before the execution starts, right? So as soon as a program is brought into main memory from the secondary memory, then from that point the program is called as a process. So in order to execute a process will need many of the CPU resources like CPU time, CPU memory, files, I/O devices in order to accomplish its task. Then these resources are allocated to CPU. These resources are allocated to process either when it is created or when it is being executed. Then in early stages, when the operating systems have been evolved, we have learned that the first operating system is the batch operating system. So if you remember how the processes have been executing in the operating systems, so in batch operating systems, the number of jobs that has to be executed are collected and stored in the memory. Okay, in that case only one single job is being executed at a time. Okay, so if only one single job is being executed at a time, all the resources available in that computer are completely allocated to this process. Okay, in contrast, later on when there are operating systems like multi-programming and multitasking operating systems, there are number of processes which are coming to CPU for execution. So in that case, there are number of processes to be executed in CPU, and then all the resources available in your computer should be allocated for all the processes that are coming for the execution. Okay, so this evolution required a firmer control and more compartmentalization of various programs. So compartmentalization in the sense, the available empty space in your RAM should be allocated evenly to all the processes, and this needs resulted in the notation of the so-called process. Now let us see the process concepts. What actually this process is. So in a batch operating system, there are the data collected from different users is called a job. So in a batch operating system, number of jobs are being executed. Whereas if you consider a time sharing operating system, the number of different processes there are considered as tasks. So it is a multitasking operating system. Whereas if you consider a single user system, a user may able to run several number of processes. So in whatever the case, whatever the aspect or whatever the data you are going to run in your computer, all these activities are same. So if you try to run a job, you will try to compile it. So when you try to execute, it should be brought into main memory. Even in the case of a program, if you write a program, you have to compile that program. So after compiling, when you try to run that program, that .exe file, that objective file which is created by compilation should be brought into the main memory in order to execute. So in any aspect, if you take all the activities involved in executing these jobs or tasks or process are equal. So all these are considered as process. So a job or a process, both are equal. And then what actually the process consists of? A process consists of, as you can see on the screen, a text section, data, heap and stack area. So the text section is consists of the current activity, what actually your process is doing. So as the current activity, in the sense, it includes the program counter. So program counter will store the next address, memory address location of the next instruction, and it also includes the contents of the CPU registers. So what are the values that your process is required to store in order to execute, and those values which are stored in the CPU registers are also present in the text area. And then we have the stack area. On the top you can see the stack area. So the stack area will consist of the temporary data, in the sense, say for example, the local variables you will be using in your program, or if you write a special function in your program, all the parameters included in that function, all the return values included in that function, and the variables which you have declared within that function all comes under the temporary data. So this temporary data is stored in the stack area. Whereas next you have the data section. So this data section, it contains the global variables which you are going to use in your program. And then we have the heap area, which is used to store all the dynamically allocated memory. Okay, so if you observe the diagram, the stack area and the heap area keeps on changing. Okay, the arrow marks on that diagram indicates the stack and heap areas will keep on changing, because the temporary variables, as the stack stores the temporary variables are erased from the memory as soon as that particular code is executed. Say for example, if you have written a function and that function uses two variables for execution. So as soon as the function execution is completed, the stack area, the data of that variables, that local variables will be erased from the stack area, so that the total space occupied by the stack area will be reduced. And as well as heap area, as the memory is allocated dynamically. So whenever the memory is allocated, the heap area increases, and whenever the memory is deallocated from the program, the heap area decreases. So that's what is an indication on that diagram with the arrows at stack and heap areas. So that is about the process contents. And then if you consider, a program by itself is not a process. So if you observe, when you write a program and save it, say for example you are writing a C program and you can save it for addition of two numbers. So you can save it as add.c. If you observe, only when you write the program and save, you cannot see the output, right? So a program is called a passive entity, that is, only writing of a program will not give you the output, whereas a process is an active entity. So what actually this process is, when you compile a program, you will be getting a machine converted code, that is called the executable code. So when this executable code is generated, it is stored in the secondary memory. So as soon as you try to run the command, give a run command in order to execute the program, this .exe file is loaded into the main memory. And right from that point where this file is loaded into the main memory, from that point the program is called a process, and from there you will be able to see the output according to the program written by you. So that's why we call process as an active entity. Okay, so with a program counter, so as soon as the process is loaded into the main memory, there will be some memory reserved for that process which stores all the details regarding that process. So there we can consider the program counter as a variable which consists of the address of the next instruction that has to be executed. Okay, and then the two common techniques for executing such a process is you can directly double click on the executable file that is created, or you can give a command in order to execute through your command line interface or through your GLR. Like say for example, if you are trying to execute a C program in Unix like operating system, you will be giving a command called /a.out. So in that case, your program will be executed. Then coming to the process states. So what actually this process state is? So this process state indicates what is the status of your process during execution. Right from the point where the process is moved into the memory to until the process when it is moved out from the main memory, the process status is indicated through this process state. So we have the new state, running state, ready state, waiting, and terminated. All these are the process states which indicates the process status. So if you observe the diagram here, each of the 5 states indicates when a process will come into that particular state. So coming to the first state, that is the new state. So if you observe, we have discussed that when you try to run a program, the .exe file is moved to main memory for execution. So before it is moved to CPU, the .exe file should be moved to the main memory. So in that case, that point of time, as soon as a process is loaded into the main memory, the process is said to be in new state. Okay, so once the process is loaded, all the required resources are allocated to that process. Say like the IO devices, the memory, all these resources are allocated to the process. So once the process is ready with all the resources, that is, if it have admitted all the resources it needs, then it is moved to the ready state. So once the process is in ready state, it indicates that now the process is ready to get into the CPU for execution. So when this process is loaded into the CPU for execution, we can say that the process is in running state. So how this process is moved from ready state to running state? As you can see, in multi-programming, there are number of processes which will appear for move into main memory for execution. So all the processes which are in ready state should be selected in some manner in order to move them to the CPU. In order to decide which process have to be moved from main memory, that is from ready state to running state, the operating system will have the scheduler dispatch. Will have some algorithms. Those are called scheduler algorithms, and this through scheduler dispatch, these algorithms will decide which process has to be moved from ready state to running state, that is to CPU. So okay, once this process is in running state, that is it is being executed, when your process wants to take some input from the user, or if it wants to provide some output from so your process have to leave the CPU and come out in order to make that event happen. So in that case, your process will leave the CPU, that is it comes out from the running state and it will be in waiting state. So until the resources are allocated, your process will be in waiting state. Once the resources are allocated and the user gives input, so if the process have taken that input, that is, now it will be ready with all the resources, ready with the input it needs. So once it is ready with the input, it is again moved back to the ready state. Okay, and then again this from this ready state the process execution will be continued by moving it to the running state. So once if your process executes correctly, completely, then it is moved to the terminated state. If your process have some interrupt or an error, then it will be moved back to the ready state. So this is about the process states, and you can see each and every state in this diagram. And next comes is your process control block. So process control block is a block of memory which is present in your main memory. So this process control block is used in order to store the data regarding a process which comes for execution. So as soon as a process loads into the main memory, a process control block is created for that process. Okay, so this process control block is also called a task control block or a process descriptor, because it describes about the process which have come for execution. So the operating system will make use of this process control block in order to gain the knowledge about the process. So the operating system will frequently check the data present in the process control block in order to execute the process correctly. And each process loaded into the main memory will have a separate process control block. So now let us see what this process control block consists of. So this process control block consists of a process state, process number, program counter, the CPU registers, and memory limits, and the list of open files, and so on and so on. If you see, there are a number of details stored in the process control block. So what are the details stored will depend upon the operating system, the type of operating system you are going to use. And we'll see each and everything which is present in the process control block in detail. So the first thing is the process state. So as we have seen, the 5 states of your process: new, ready, running, waiting, and terminated state. So all these states are represented in the process control block. So the first part is nothing but your process state, which indicates in which of these 5 states your process is being present. And then next is the process ID. So in order to identify a process from all the available multiple processes that are coming for execution, the operating system will allocate a numeric value to each process that is appearing for execution, and that numeric value is called the process identifier or process number, and simply we can call it as a process ID. Okay, so see, as in order to identify you, we have roll numbers. So in the same, in order to identify the process, we have the process IDs, and then we have the program counter. So when you load a program into the main memory, so each and every instruction will occupy some memory location. So each and every instruction will occupy a memory location, and each location will have some address. So in order to load an instruction into CPU for execution, the operating system should know what is the address of that instruction. So that address of the address of that instruction is placed in the program counter, which will be present in your process control block. And then next we have the process accounting information. So accounting information in the sense the description of all the resources which your process is going to use is placed in this process accounting information part. So like say for example the CPU time in the sense right from the time where when your process have moved into the CPU and until it terminates, what is the complete time taken in order to execute that process is called a CPU time. And real time in the sense right from the point where the user tries to execute a program to until he sees the output and the process gets terminated, time taken is called the real time. So all these are present in the process accounting information. And then we have the CPU registers. So what all the registers or what all the values your process is going to use are placed in the CPU registers. So there are number of registers present in your CPU. Say for example, if you want to load an instruction into the CPU, that instruction is taken from main memory and loaded into the instruction register present in your CPU. So likewise, in order to store the values of your variables, we have registers called accumulator register. So likewise, there are number of registers present in your CPU which consists of different functionalities. So all these details, what are the registers your process is going to use while executing, are present in CPU registers part in your process control block. And then we have CPU scheduling information. So scheduling information in the sense, this includes the priority of a process. So priority in the sense, it indicates the operating system that how many processes are there in the queue for execution, this process should be executed first. So that indicates the priority of a process. So this priority is indicated based on a numeric value. So all this information is present in the CPU scheduling information part. And then memory management information. So all the memory addresses which your process is going to use, where the values of your variables are being placed. So all the memory information, all the complete memory, which what is the amount of memory that your process requires in order to execute, all these details are also stored in your process control block. And then lastly we have I/O status information. So what are the input devices your process is going to use, what are the output devices. So when they have to be allocated, that is as soon as it is created or during the execution. And then the list of open files, what are the files your process is trying to open while executing. So all these are present in your process control block, which indicates an operating system in order to execute the process correctly. And then we have threads, a small concept of threads. So a thread is a basic unit of CPU utilization, or you can think a thread as a part of a process. So a process can be divided into different parts and each part is called a thread. So this why do we need to divide a process into thread? Because when we have a multi-programming system or a multi-processing system, in the specific time when that is required in order to execute a single process can be completed within short time using this threads concept. Number of threads can be created for a single process, and in all these threads can be executed simultaneously using multi-threading concept, which you will be seeing in later topics. Okay, so if your process, if your say for example, if you are running a process like Word document, so your Word document may have a single thread of process. So if you are having only a single thread, that is only one single process, your single thread will have control over all the resources present in your computer. So same as a process have some data, the thread will also have a particular data. Like we have process ID for a process, a thread will also have a thread ID. And say for example, the same word processor, you can divide it into two threads. Like first thing is the text editor, so with which you can edit the text in your Word document. So as soon as you type a word, if you have any spelling mistake in that word, so once after writing your word and moving out from that and giving space, you can observe a red color underline under that word, which indicates the user that there is a spelling mistake in that word. So this is done by the spell checker program present in your word processor. So likewise, if you consider here the text editing is one thread, can be considered as one thread. whereas the spell checker can be considered as other thread. So a process can have multiple threads. Okay, and then if your process have multiple threads, your process control block should include all the details of these threads also. So the process control block should be expanded in order to include all these details. That is about threads, and thank you for watching this video. In next video, we'll be discussing about the process scheduling.